tonight, we are going to talk about programming's greatest mistakes, including me. It's kind of hubris, really, put myself up there with programming's greatest mistakes. But no, we're going to take a look at some of the stupid things that programmers and designers and Americans have done over the years. But before we start, I just want to make, this isn't a content warning, it's not a trigger warning, it's a reassurance. It's a content reassurance. I'm not going to talk about any incidents where people got hurt or died, okay? No aeroplanes, no medical equipment, nothing where software has hurt or killed people. But software has hurt and killed a lot of people, okay? So let's just take that as read and move on. I would also like to thank the following YouTube accounts for pointing out all the times I was wrong on instances of this talk that have already gone up on YouTube. I think I've addressed the things that you pointed out, and I look forward to finding out what I get wrong in this talk when this one goes up. So I'm going to start by talking about one of my own mistakes. Just A, to make it clear that we all make mistakes, and I'm not sort of saying I'm better than anybody else. B, just as a kind of point of reference, so that then we can compare the other mistakes to the one before. When this happened, so this is going to make me sound really, really unprofessional, okay? And so I want to put a disclaimer in there. When this happened, I was about 6 months away from a nervous breakdown, okay? I remember that around the same time, the HR person was coming around to all the desks to get people to go to a pension presentation, and I looked her straight in the eye and said, I'm not going to need a pension. So that was my state of mind at the time. But yes, I worked at this company. We made membership management software. And you could create very complicated queries against your membership database. And then you could save that query into a file, which, for reasons that I can't remember, had the extension MED. And we released a new major version of this software, and the first thing it did when people opened their existing query files was to corrupt them and stop them from working, both in the new version of the software and the old version of the software. And so the support chap came to me and said, and I quote, Mark, the new software has fucked the med files. And I went, oh. And he went, look, can we fix this? And I took a look at it, and I went, oh, yeah, no, we can reverse that out. I can write a little application. He went, write a utility to fix them. And I went, so you want me to write something to unfuck the med files? And he said, yes. And so I booted up Visual Basic 6, and I started a new project. And you know, the two hardest problems in software, naming things and cache invalidation. And I went, what do I call it? I'll call it the medfile unfucker. I'll think of a proper name before we release it. Once I'd done that, I kind of rolled with it. So the dialog box that it popped up said medfile unfucker in the title bar. And then it had a file selection sort of button that said, choose file to unfuck. And then when you'd chosen it, it just had a big button that said, unfuck now. And when it had finished, it said, file unfucked successfully. And I gave it to Chris. And I said, can you just test that, make sure it works, and then I'll sort of make it right for releasing to the customer. And then I didn't hear back from him. And then the next afternoon, the managing director turns up at my desk. Because Chris released it. Because of course he did. He released it to all our customers, and these are the kind of customers who have paid £1.5 million for the software and are paying you £500,000 a year in support contracts. And the senior developer architect at the company has just sent them a piece of software which was literally called medfileunfucker.exe. Loss of face, bit of a dressing down. I don't think I did very well in my annual review that year, but enormous amounts of money were not lost. No customers were lost. Everyone just went, just don't let him name anything else. And they moved on. Now compare that, and that's the sort of thing, most of us in here, we make mistakes, that's the kind of thing that happens, and nobody dies, and huge amounts of money are not lost, and we get away with stuff. And then you get mistakes with real price tags. So Y2K is a really obvious example of this, so I'll put it at the start. Y2K, and the terrifying thing now is, I turned 50 this year. Hands up if you were born after the year 2000. Yeah, see, that's too many hands. It's only like 3 or 4, it's too many. There are people who can like vote and have children and do things and who don't remember this at all. So for the benefit of you people, Y2K, this was a bug. Basically, what you have to understand is that back in the 1950s, this was both data storage and programming. These are punch cards, and you wrote code, and then you encoded a line of code onto a punch card. This is a single line of code. One punch card, one line of code. And so this is why Fortran, the original version of Fortran, you couldn't have more than 80 characters in a line because there are only 80 usable columns on the punch card. And it was used for storing data as well. And so each column on that punch card would be 1 byte of data. So storage was kind of at a premium with punch cards. And even when we started to progress beyond that and get into machines that had kind of working memory and stuff, this is what memory looked like. This is core memory, magnetic core memory. If you've ever been on a Unix or Linux or Mac OS system and it says like segmentation violation core dump, the reason it's called a core dump was because it dates back to core memory, where it would just go, this is what was in the memory. This is not under a microscope or anything. This is just a close-up photo. This is lots of pins with lots of wires running through them. And these things were knitted. Essentially, women primarily would use needles to feed very fine wire through very small holes in very small needles. The labor for making one of these was ridiculous. The result was that a single byte of core memory cost $1. So byte, kilobyte, megabyte, gigabyte. So yeah, who's got an iPhone 14? That would be $12 billion just for the RAM in that iPhone. So yeah, it was at a premium. And we needed to store data in these things. And COBOL, which was widely used by business developers, terrible language, but never mind. And this was how it defined date. So pick 9 this is a char field, but it can only contain digits, and it's 6 characters long. YY, MM, DD, or potentially DD, MM, YY, or if you were American, MDY, DMY. I don't know how they do it. I just know it's wrong. Point is, they only used 2 digits for the year. And they went, well, it's going to be 19 something, isn't it? Why do we need to put the 19 on everything? That's just wasting space. And you're kind of like, yeah, no, that's fine. This is Bob Beamer. And Bob Beamer pretty much straight away said, this is fine, okay, but actually, we're only 50 years away from this not working. And honestly, we're only kind of 10 years away from people starting pensions where the projected date when they're going to start drawing that pension is going to start with 20. So we can't keep doing this. So he was saying that in 1959. And he was still saying it in 1969. And he was still saying it in 1979. He was like the little Dutch boy with his finger in the dam. He was still saying it in 1989 when people finally started to listen and have meetings. They were still having meetings in 1995. I got my first very, very highly paid, thank you very much, job fixing a Y2K issue in 1997. Basically, all the programmers in the world for about 3 years, and there were far fewer programmers in the world then, by the way. So we didn't have conferences like this. If you'd had like the same ratio, then it would just be these 2 guys here. There's a lot more programmers now. We all said, oh, I think my day rate is going to be what, £800 now, maybe 1,200, whatever you can go. So I had to rewrite entire COBOL systems into Infomix 4GL, which was a thing then, to fix the Y2K bug. And then, of course, nothing happened. And everyone went, well, that was a fuss about nothing, wasn't it? And you're going to like, no, we've spent $500 billion is a conservative estimate of how much it cost. The mistake in this case, like I say, what they did in 1960, when core memory cost £1 a byte and data was stored on punch cards, made perfect sense. It was leaving it too long before fixing it, leaving technical debt to fester for 45 years before starting to do something about it. That was where the mistake was, and that's why it cost $500 billion to fix. And you'd think we'd learn from that, and you'd think people wouldn't do silly things like that anymore. And then this happened last year. At the start of last year, Microsoft Exchange, the thing behind Outlook, started to crash and said, oh, I can't convert 2201010001 to a long because it's too long, I don't know, whatever it is. But yes, 2112312359 was fine, but for some reason somebody at Microsoft decided that they were going to do YYMMDDHHMM and then pass that string into a 64-bit integer, and it didn't work. So yeah, there you go. That happened. There was, of course, I think they've basically fixed this now, but after we'd fixed Y2K, people kind of went, so the next one that we should look at is in the year 2038, Unix's 32-bit time value is going to overflow, and it will revert back to being minus the 1st of January 1970, or whatever that would have resulted in. They've patched this now by changing it to a 64-bit integer, which theoretically, well, it's going to outlast humans. Let's put it that way. But this is my favorite one. I saw this on the Stand Up Maths channel on YouTube. The Kennel Club. In the United Kingdom, the Kennel Club is where you register your pedigree dog. If you spent like £3,000 on a Shih Tzu, and you call it Mr. Fotherington Splendid, then you go to the Kennel Club and you go, hello, I'd like to register my Shih Tzu. His name is Mr. Fotherington Splendid. And they go to their database and they go, yes, well, there are there have been 37 Mr. Fotherington Splendids, and so yours will be Mr. Fotherington Splendid 38, and I'm afraid that means we can't enter him into our database and you'll have to think of a different name, because you can only go up to number 37 with the dog names. So that name, that number, you can't go past 37. Now, can anyone who hasn't seen the stand-up maths thing guess how they're storing the number in their database that would cause it to overflow at 38? So I'll give you a clue. It's a 6-character field. Nope, not hexadecimal. Roman numerals. Thirty-seven in Roman numerals is XXXVII. Every number up to there in Roman numerals is less than 6 characters or less. 38, XXXVII, and it doesn't fit. The hilarious thing is the fix wasn't, let's not store the bloody number in Roman numerals. It was, let's add 2 more characters to that field. So that was an actual kind of individual specific mistake. I also want to talk about kind of just general things that are wrong in our industry and enterprise, just as an example. Enterprise, the definition I found was a business plan or project, especially one that is difficult or that may fail or lose money. I think that's the perfect definition of, what constitutes an enterprise project? What constitutes enterprise software? Was it delivered on time, on budget? If it was, it's not enterprise, yeah? I think that's fair. If it wasn't delivered, or it was delivered late, or it went 5 times over budget, then probably enterprise. Government projects, public sector, just everything like that. And enterprise is so weird because it watches trends and it pays Gartner subscriptions and reads ThoughtWorks sort of radar thing and everything, so it can find out what the new trends are so that it can adopt them and fuck them up. This is the scaled agile framework for lean enterprises. Not your big, heavy enterprises with lots of process and rules and 5 middle managers for every developer. No, this is for lean enterprises. There's somewhere, what have they done with them? They're here oh, look, no, there. That's the programmers. Yeah, shift left. So yeah, there are versions of the scaled agile framework for people who go, oh no, that looks a bit sort of slapdash to me. This is Auto Scrum 1.1. This is Accenture. I mean, I don't even. And yet again, look, there's the programmers. Right down at the bottom there, nobody cares about them. So yeah, that's how you build software with Accenture, and that's why it costs what it does with Accenture. You sort of, well, okay, it's really company, they've got processes and all this sort of stuff. Has anyone seen this before? So this is from Deloitte. This is actually from an interactive website that they make. The 2 previous slides are single dots on this chart. And it's like they made it look like the London Underground. And if I'd been the London Underground, I'd have been going, can you not do that? You're making us look bad. So yeah, I don't know what enterprise has cost us over the years, but it is trillions and trillions of dollars. And I think they maybe once delivered a working file deletion utility, maybe? I don't know. This one's quite fun. So we think of CPUs and GPUs and the hardware. That's hardware. It's not software. It's not programming. But actually, people program the FPU and the CPU and the GPU, and it's just that their code compiles to a map of some silicon and transistors that work together. The Pentium floating point unit. So the Pentium was the first processor from Intel where every SKU, every version of the Pentium came with a floating point unit built in. Before that, you could buy a 486DX, which had the floating point unit built in, but you could also buy a 486SX, which didn't. And then if you'd done that and went, oh, I wish I had got the floating point unit, you could buy a 487DX, I think it was, which was like an add-on floating point unit. But the Pentium, the big marketing thing for the Pentium was they've all got the floating point unit, which was really important for playing Quake, I think, primarily. That was pretty much it. So this was the Intel Pentium, and they sold a lot of these. And these things flew off the shelves. Now, quick question, very simple. What's 4,195,835 divided by 3,145,727? That's right, it's 1.33382. Unless you asked the Intel Pentium's floating point unit, which would tell you that it was 1.33374. Now, like I say, all that means is that possibly your rocket in Quake is going to go ever so slightly off course. And so Intel, I thought, quite justifiably went, this isn't actually going to, there were a few others that it got. It wasn't just this one sum, but it was a very, very edge case. It didn't happen very often. They just hadn't tested their floating point unit with the whole of maths before they released it. And so, of course, it didn't take people long to find the bugs once it got out there. And so Intel started out saying, if you can prove that this problem is affecting you, then return your Pentium and we'll send you one of the new ones where we fixed this. But it pretty quickly changed to, oh God, just send it back and we'll send you a new one. So that's what they did at a cost of $475 million, which is quite the write-down, especially, and this is back in the 90s, when that was a lot of money. I mean, that buys you like, what, half a Patriot missile now? Or so, NULL. Java people, mostly, GOTO. Yeah, you're Java people. I'm a .NET person, sorry. It's better, though. Nah, that's not fair, you're catching up. But we both have, you have a null reference exception, I have a null reference exception. We are brothers and sisters in pain. And non-binary siblings. So yes, null, we know it was a mistake, and we can put a rough value on it because Anthony Hoare, he's got letters after his name, he's a British computer scientist, and he was the guy who invented null, and he has called it his billion-dollar mistake. He called it that in a talk he gave at QCon in 2015. And Anthony Hoare was working on ALGOL W, which was ALGOL with records. And so what he actually invented was this concept of a record, which was a thing that had multiple fields, which could either be scalar values or a reference to another record. Now, before that time, we'd only had scalar values. So if you didn't assign a value to a string, it was an empty string. If you didn't assign a value to an integer, it was 0. But now, if you don't assign a value to a reference, what is that value? And so he invented the word null to represent what it meant when there was a 0 in a reference, which then meant that you had to write code that looked like this to say if P is null, then do something else, if M is null, then do something, and so on and so on. And here we are, however many years later, 40, 50 years later, trying to work out ways. In C# we now have this notion of nullability checking, and you can put a question mark after the thing that says, this might be null. Please, I'm telling you this might be null. Now tell me if I'm using it somewhere without having checked. This method might return null, this property might be null, this parameter being passed in might be null. And also, if you don't put the question mark on the end and then you call a method and it hasn't got the question mark, it'll say, you probably shouldn't, you should check that's not null before you pass it to that method. So we're trying to fix it, but you know. And then there's kind of the people with discriminated unions just going, option of tea. And you're going, I would prefer option of coffee. Ha ha. Thanks, Denny. So yes, null, the billion-dollar mistake. The Hartford Center. This is fun. Sometimes programs do it. This is kind of the key thing here. Programs do exactly what you tell them to do. And then we write programs that essentially print out instructions that tell people what to do. And then the people do that. For example, for a long time, computer-aided design, we think computer-aided design, you think of AutoCAD and things like that. And AutoCAD, you go, what's the difference between AutoCAD and like 3D Max? And the difference is that in 3D Max, you can't tell it what things are made of and what tensions and stresses are going to be applied to things in your model in the real world. AutoCAD is designed to model those things so it can tell you what strength of RSJ you're going to need and all that sort of thing. Back in the day, AutoCAD or CAD software was a bit more like MATLAB, and so you would program the stresses and forces and materials and everything in, and it would go, okay, so you need this kind of bolt and this kind of girder and everything else. And so if, say, you were designing a building and you forgot to account for the lateral shear force that could be caused after accumulated snow on a sloped roof started to melt and went whoomph sideways, so you'd only accounted for the weight of the snow pressing downwards, then potentially bad things could happen. There was nobody in the building when that happened, okay? But that is exactly what happened. The person did not account for the fact that snow moves after it's landed, and the roof of the building collapsed. They'd followed the output of the CAD model perfectly. Garbage in, garbage out, roof down, $90 million to replace it. So yeah, that's where programming meets the real world. And it gets a lot worse where programming meets the real world. But this is my favorite one, I think, in the whole talk, because they deserved it. And so do all the others. Knight Capital is a hedge fund. Sorry. Knight Capital was a hedge fund. Hedge funds are mainly questionable ethical investment bodies. They tend to, they take short positions on things, which is basically going, I bet you're going to fail. And other sort of interesting things like that. You know, you trace the concept of the stock market back to its origins. It was actually right here in the Netherlands. The Dutch East India Company were trying to raise money to build ships to go to India and steal their stuff and come back here and sell it. And so they said, if you give us money towards our ships, then when we've gone and stolen the stuff and brought it back here and sold it, then by the way, there was a British East India Company as well. I'm not having a go at the Dutch, right? There was an everything East India Company. It's all white people, okay? We're all bad. But yeah, stock markets were designed, they were like venture capital. They were like, I've got an idea. If you think it's a good idea, give me money. And then if the idea makes money, then I'll give you money back. And that was how it worked. And then now that's changed to autonomous algorithms running at sub-millisecond speeds, executing trades and creaming off fractions of a percent of a cent, but thousands and thousands of times a second, and just sucking all the money out of the world and giving it to Elon Musk. So Knight Capital had, in the sort of early days of electronic trading, people set up servers like right next door. They would hire very expensive office space next door to the New York Stock Exchange so that they could literally run fiber optic cables through the wall straight into the trading computers. And then the hedge funds would write these programs that they just released and went, just run. And so Knight Capital did this. And the New York Stock Exchange went, we're not having this dark pools. We don't like this. It's bad because, not because it's unethical and it's not contributing anything to society and you're just strip mining the economy. No, the New York Stock Exchange said it's bad because we're not getting our cut. And so they created official dark pools actually running inside the New York Stock Exchange, which had a specific set of protocols. And so Knight Capital had to rework their software to run inside this new system. And they only had 6 weeks to do it. And so they basically hacked around the existing software, and there were things that they had been doing that they weren't doing anymore, and there were things that they needed to do now that they hadn't been doing before. And this is highly optimized software. The way you succeed in this business is by being a microsecond faster than your competitor. And so there's lots of bit masks and this sort of thing. And so they were keeping some of the same kind of 16 or 8-bit fields and just repurposing various of the bits. And so they did this. And at 9 o'clock in the morning, on the first day that this went live, they deployed their software onto 8 of the servers. And in the first 30 minutes, it spent $800 million on trades. And Knight Capital would have to pay whatever these trades cost, they had to pay at the end of the day. And they went, oh no, something's gone terribly wrong. And so they looked and they went, oh, the software didn't roll out properly. It only went onto 7 of the machines. It didn't go onto that 8th one. That's probably what the problem is. That wasn't what the problem was. The 8th machine was the only one that had the right software. Essentially, there was a flag that in the old system had been used in test mode to say you can't make more than a certain number of trades per second. It was a limiter. It was kind of like a fail-safe. In the new system, somebody was addressing that same bit, but treating it as something else entirely, and the thing that was supposed to limit the number of trades that it could make was pointing to something else, which was always turned to off. And so they updated the software onto the 8th machine, so they were all running the same version. And by the time they just turned the machines off at midday that day, Knight Capital, by 5 o'clock that afternoon, had to pay $4.5 billion in trades, which they didn't have. And so they were acquired by Goldman Sachs and then disappeared 6 months later. It ended up costing Goldman Sachs $440 million after they sold the shares that it had bought and all that sort of stuff. But $4.5 billion was what did for Knight Capital. Okay, let's talk about bugs in space. Because in space, no one can set a breakpoint. Mariner 1. Mariner 1 was a NASA mission to Venus before we knew what Venus was like. And so Mariner 1 was supposed to go to Venus and go into orbit around it. And now, Mariner 1, it was programmed in Fortran. And Fortran is short for Formula Translator. And the whole point of Fortran is that the majority of software at the time was scientific formulas, mathematical formulas, and you could put those into Fortran and it would turn them into machine code. This was an insanely clever idea back then. And so a mathematician wrote formulas, and then a programmer kind of translated the formula into Fortran, and then Fortran translated it into machine code. And the mistake here wasn't actually the programmer, it was the mathematician. So this is what Mariner 1 should have looked like as it sailed majestically through space towards our nearest neighbor. But the mathematician, so the sum on the left, the thing on the left, is .rn smoothed over time. That hyphen over the top means smoothed over time. So it's going to go up and down like this, and we want you to plot the average so it's something kind of like this. But the person who wrote the formula down didn't put the hyphen in. But the rest of the stuff was exactly right. And so where it went, if this smoothed line exceeds a certain amount, became, if this jaggy line exceeds this amount down here, bad things are happening. And so Mariner immediately informed Mission Control that bad things were happening, and Mission Control pushed the big red button 4.5 minutes into the flight and blew up Mariner 1, even though it was completely fine. And this particular equation, once Mariner 1 had got out of the Earth's atmosphere, it was done. But no, it said it was broken, and so they blew it up, and that was $18 million in 1960s money up in smoke. So that's like $1 trillion now or something. And it's not the only NASA mission that's gone terribly wrong. The Mars Climate Orbiter, I did kind of think, 2 NASA missions, but this one, very different reason. And there's a lesson here about ubiquitous language, I think is probably the best way of describing this one. So this is the Mars Climate Orbiter. It was supposed to go and float around Mars for a very long time, monitoring storms and the atmosphere and temperatures and that sort of thing. But it didn't. It never made it because of these. These are centimeters. These are what the entire world and NASA use to measure things. But Americans don't use centimeters, they use inches. Centimeters are quite a lot smaller than inches. So if this man is 5 centimeters tall, this man is 5 inches tall. You see, it's quite different. Like I say, NASA use metric because they work with a lot of external partners, European Space Agency, Japan, China, that lot. Lockheed Martin use inches. And so Lockheed Martin said, it should be this many inches or feet or whatever it was, and NASA fed those into their software as centimeters, which meant that the planned trajectory for the Mars Climate Orbiter would have taken it into an orbit at 226 kilometers above the surface of Mars, and where it actually went in was 57 kilometers above the surface of Mars, which is in the atmosphere and on a death spiral. And so it crashed into the surface of Mars and spread $327 million all over the Martian surface. Fun. European Space Agency, we're no better. Ariane 5. This was the first flight of Ariane 5, and everything went absolutely fine, and the rocket ignited, and it soared majestically into the sky, and it flew beautifully, and the assembled dignitaries were like, ooh, look at the pretty rocket flying up like that. And then the software attempted to store a 64-bit floating point value in a 16-bit address because they'd copied and pasted code from Ariane 4, which had been written 20 years previously on much older software. And so the 64-bit floating point value massively overflowed the 16-bit address, and that happened. And the hilarious thing is that they didn't even need that code because the Ariane 4 rocket had a completely different pre-flight and initial flight system compared to the Ariane 5 rocket. Ariane 6 soon, though. That's going to be fun. So yes, if you're going to copy and paste code, make sure that you check that you need it and that you've checked it and, test it. This is one of mine. Actually, the same company where I wrote the medfile unfucker. I had managed to persuade them that we needed to rewrite the software because it was in a thing called GOTO SQL Windows, and that was no good anymore. And so I wanted to rewrite it in C#, and I said, "Can I rewrite it in C#?" And they said, "Yes." And so I did. And I was about 18 months into the project, and I started so I think I started in 2003 or something. And then 2006 came along. So this was a Windows Forms project, which was the original framework for creating Windows applications with C#. And then Microsoft released WPF, new and improved, XAML, better data binding, all sorts of exciting stuff. And I went, ooh, shiny. And decided that I had to port the entire thing from Windows Forms to WPF. And that was actually what caused the nervous breakdown. And they abandoned that project entirely. They probably spent £100,000 on it at that point. So that didn't cost, well, that and my sanity. Literally 6 weeks in hospital. So yes, if you start a project with something, finish it with the same thing. Yeah, if you started a project with Svelte 3, you can wait for Svelte 4, or probably just skip it entirely and go straight to 5. Also, if you believe that your work is incredibly important, you probably need to take a holiday. The belief that one's work is of paramount importance is the surest sign of an impending nervous breakdown. Somebody who probably didn't think his work was very important back in 1995 was a young Brendan Ike. Mark Andreessen and Ben Horowitz just poked their head round his door and, "Brendan, are you busy?" Well, we're shipping Navigator 2.0 next week. Yeah, about that. This Java thing, and people are using it to make applets that make buttons glow and this sort of. We thought, what if Netscape had a scripting language built into it that could do that? Yeah, that sounds like quite a good idea. Can you just knock it, just as like a tech demo? Doesn't need to be particularly great. Just do that, yeah? So he went away and worked for 7 days. And when you want to implement a programming language extremely quickly, and you've been to MIT, you write Scheme, okay? You write a simplified version of Lisp. And so Brendan went, look, I've done it. It's basically just Scheme. And they went, ooh, that's a lot of parentheses. See, we're trying to persuade people to move away from Java. So is there any chance you can make it look more like Java? And so he went, yeah, all right. And he went away. And it went out in Netscape Navigator 2.0. And things like this happened. So array equals not array is true. And type coercion. He put type coercion in there because he wanted it to be a dynamic system, and he wanted it to be very forgiving. So 2 features in there to make it very forgiving. Type coercion, so if you have the number 1, but you're trying to treat it like a string, JavaScript will treat it like a string. If you have a string that contains 1, and you try to treat it like a number, in some cases, JavaScript will treat it like a number. So B plus A plus A plus A equals banana. This is the thing about JavaScript. In any other programming language, that's a syntax error. In JavaScript, it's a banana. It's a banana because what this actually means is B plus A, okay, plus A, which is the same as like maths.abs A. It's plus is give us the absolute value of A. So if it's negative, make it positive. And so JavaScript comes along and goes, well, A isn't negative or positive, so this is invalid. So instead of throwing an error, I'm going to return the value nan, not a number. And so we get banana. And then we get this. Document.all is an instance of object, that's true. The type of document.all is undefined. Does document.all equal undefined? No, it doesn't. Does document.all equal null? No, it doesn't. Okay, if I type coerce null, then does document.all equal null? Yes, it does. And you know, the sort of, if you could go back in time and change something, what would you change? And people go, oh, I'd kill Hitler. I'm kind of torn. Because I could also go back to a year. I go back to 1994 to Netscape and find Brendan and go, next year, Mark and Ben are going to come to you and ask you to knock together a tech demo of a scripting language to run inside the browser. And I just want you to know that by 2023, 50% of all code written every day will be written in that language, and it'll be in space, and it'll be on servers. It will be everywhere. It will be running on smartphones. What's a smartphone? Wait and see. And so please, 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 just start now. So you've got a year, and just make because he's a smart guy. Brendan Ike is a smart guy. He's a dick, but he's a smart guy. And he could have made a really good programming language if they'd given him more than 10 days to do it. So yes, that's all I'm saying. And then maybe I could go back to like 1940, 1932, and then kill Hitler, and then just dick around for 60 years, and then as an old man go to Brendan Ike, if I remembered. Anyway, that's what I do. So yes, JavaScript, I don't know, priceless. Honorable mentions to Heartbleed Log4j and JavaScript's ECDSA algorithm, the thing that validated keys, where basically if a couple of the things were 0, then everything worked. So those were all pretty good. But just very quickly to finish on, the Soviet early warning system. God knows what the Soviets were using for computers in the 1980s, but this man is Lieutenant Colonel Stanislav Petrov, and he received an alert from the Soviet early warning system one day that said 5 intercontinental ballistic missiles were headed for various targets in the Soviet Union, and he should immediately launch a counterstrike. And Lieutenant Colonel Petrov decided that it was probably a false alarm, and he did not launch a counteroffensive. And he was right. It was a false alarm. They weren't missiles. They were sunlight glinting off clouds. Because Lieutenant Colonel Stanislav Petrov knew that computers are stupid and the people who program them are incompetent, and we definitely shouldn't trust them when it comes to extinguishing all life on this planet. Thank you, Lieutenant Colonel Stanislav Petrov. Thank you for your service. Nearly all known life in the universe. And that's it from me. Thank you.